Okay, so let us begin with the second talk, which is the third talk actually. So Michael made it to Wrocław. I'm really happy that, yeah. Yeah, so our next speaker is Michael Staib, who is also part of the GraphQL Technical Steering Committee and also author of Hot Chocolate and other frameworks with cool names such as Strawberry Shake or Green Donut. Yeah. And he will tell us about new features that are coming to the GraphQL specification. So please welcome Michael Staib.
Yeah, hi everyone. So after picking the wrong city in Poland, I finally arrived here after 4 hours in the car. But okay, it worked out. So thanks to Mirumee to get me from Warsaw to Wrocław, which looks very similar if you look at it from yeah, almost the same. So let's talk about what's next in GraphQL. Or building modern applications with future GraphQL. How the new GraphQL stuff will change how we will build applications in future. Or maybe if you are feeling adventurous, you can start with that even today. But let's have a look at that. So when I started building that talk about future of GraphQL and all the nice things we are working on, I actually did it because a lot of people were talking about GraphQL has stagnated or why is GraphQL not moving. And actually the idea of this talk is also that you get the feeling what we are actually doing behind the scenes to push it to the next level. And if we look at GraphQL at the moment from the consumer perspective, the last biggest change that we did was subscriptions. But Lee Byron already, if you remember a talk from, I think it was React Europe, already outlined actually all the cool stuff we are working at the moment on, like live queries, defer and stream, and other cool things. So when we look at GraphQL, and this is probably the simplest GraphQL query you could write. It's essentially asking our server for the currently signed in user and the name. And GraphQL actually was designed to put us in control of how we get data. So if we send this query to our GraphQL server, we get something that closely aligns our request. And Facebook designed that actually with the aspect of mobile applications and slow networks. So this is the basic stuff, just to get us slowly in. So GraphQL mainly was concerned with network payload in the past. But it's also great, and was also great then, with relations. Drilling into relations of data, fetching other stuff. But what can happen here is that we are actually drilling in costly connections. So friends could come from a different database. We might have to aggregate database calls or even REST calls behind the scenes. Before we get into what the problems are here, let me introduce one other concept. And if you're into GraphQL, you know that. It's fragments. And the potential of a fragment is essentially that we talk about data components. But at the current version of GraphQL, it's more like a data contract. But it's a data contract for our UI components. So I like to see them as a data component. So if we look from a relay perspective, for instance, on top of this, or into this, is that these data contracts actually allow us to collocate UI components and data contracts. So if we look at modern applications, and this is a bit of an example of a modern applications for me, let's have a look actually at it, then we are composing a lot of these components. And what the beauty is then with GraphQL, and that's for what they have designed it is no matter what I do in this application, it's actually just one data fetch. For instance, I loaded this application, so it's one GraphQL call. If I drill into, for instance, here the Bitcoin, it's just another GraphQL call. And if I, for instance, switch something here, it's just one more GraphQL call. So that's a typical thing that we have with GraphQL. So what else is here modern is that actually everything lives. So you can see that here my data components live, they update constantly. And if I go back to my overview, it's the same thing. Everything lives here, the data lives. But also this application is actually very reactive. So it doesn't take a lot to move around here. And as I said, everything has one data call. So let me go back to the slides. So GraphQL in the beginning was optimized of reduced network calls. So I said that before. But this has a problem that we put everything in one network call, and we want to optimize for this one network call, but it gets maybe really slow because we didn't optimize for minimizing the time to the important data. So if you look at my application that I have here, you can see there are a lot of elements here. For instance, we have here a graph for the Bitcoin, and the graph actually is an expensive thing. And if I swipe to the side here, you can see I have a lot of other graphs here with more data. But actually, when I first load this application, I only see this first graph. So in order to optimize this application, we can optimize now the time to get the first data. And with that, empower our consumer of our API, the front-end developer most certainly, to really build this awesome experience here and get a fast application. So let me just dive into our GraphQL tool here. And the best feature of this GraphQL tool is actually that we can, okay. No, okay, so let's dive into our GraphQL IDE a bit, and this is actually the query that powers our front end there. So this is how we fetch the assets. So if I run that, you can see it takes a bit because there's a REST service involved, and it takes like 1 second to get the data here. So now with defer and stream is one of the first features I want to show you. I can now optimize my data call and say, for instance, actually, I don't want all these nodes because I wanted the Bitcoin for the Bitcoin graph that I have. That I want to have first. So I stream the data here, but I say I want the first entry I want to have immediately. So that's my initial count. And after that, give me all the rest of the data. But I already know that this part actually, to get the price points, you can see that's a lot of data I have here, is actually the expensive part. So I'm going to add a second thing here, and that is the defer directive. So I'm saying defer this part and stream the nodes. And then I can rerun my query here, and you can see the first data arrives now in 270 milliseconds. So suddenly my application is really fast. And in my GraphQL IDE here, I can drill into actually the patches and look what's going on the wire. So I can see that now I get the first price first here and adjust that, but then it tells me there's more. And I could go through here, for instance, to the 13th part, and then you can see that other data, like the graph data, is really arriving. So stream and defer really allow me now for modern applications to define in a single query, a single HTTP post request that I do. It's not WebSockets or something. It's working over HTTP1, but I have this new awesome experience. So, and if we look at our component here that makes this all possible, it's actually for the developer now, just adding this little thing here, and you have a complete new experience. And this especially if you power it with something like suspense in React. Okay, but With great power comes great responsibility, and that's a part where I tell you why it takes so long to get it in, because Lee showed us this feature already in a I would say, keynote presentation in 2016, so 6 years ago. So why did it take us so long to make it work? So this is just the last, I would say, like we are talking about this problem the last 2 weeks in the working group, because so we looked at the feature. This is really a nice query here. Maybe look at the fragmentized version. It's essentially the same that I had before. And now maybe a developer is sitting in his components and he thinks, oh, my friends all did this defer and stream stuff above in their components. It works now faster. So let me optimize also my defer here. So I'm adding a stream here. And then we execute that query. And suddenly, you can see already my UI freezes. And our optimized query now takes a lot longer. You can see it's taking forever. And when we look at our patches, we suddenly have over 3,600 patches. Because if you don't do it right, actually defer can DDoS your server very easily. Now I can just define small queries against your nice GraphQL server and kill it very, very quickly. So the current discussions on this is to defragmentize, to merge essentially these differs and get rid of differs that may be unintentional. Because what you want to have is more like a deferrable. So you want to tell the server, ideally, I get that later. But maybe there's something not so good with it, then the server should optimize it. Because the main effect that I want to have is a fluent UI. And that is where we should talk about fragment modularity. And that's another feature, but ties very nicely into our problem here. So when we talk about GraphQL in present, it's mostly about minimizing network responses and optimizing these network requests. So we want to have reliable data fetching that is fast over mobile networks. That was the original intention. But when we look at our fragment structures here, for instance, then what the GraphQL server originally does is defragmentize. So essentially, if we look at these fragments here, when the GraphQL server essentially optimizes this query, it looks more like this. So the first thing a GraphQL server is doing is throwing out all these fragments and merging all the fields so that we don't send over unnecessary information. But with defer and stream, we are suddenly having like deduplication of data. And if we fix that problem in the defer spec, we would lead essentially to the same behavior where we reduce these deduplications, but then there is a problem for the client developer to know if the data for a certain component really arrived. So, ideally, this could be solved with something like a label, and we tried that actually. It didn't work out, because if we got rid of the defer because we optimize it, then we also don't get the label sent over the network transport. So what we ideally want to do, and that's not only about defer and stream, is reason about fragments in isolation. So if you think more about fragments, and I told you the term of a fragment or a data component, we actually want to use it like a component. If you think about this price details fragment, maybe we want to reason about it in our client code that it's something awaitable, where I can say, okay, I have the asset, now I await the price details fragment. And at some point, I will get that. But because we defragmentize in the server, we don't have a sense of a component. Maybe also I want to have a check more like this in line, but again, I want to have the structure of a fragment in my client application. So a trick that actually somebody at Facebook came up with is to misuse the dunder type name field and then alias it. And then we actually would get an information in our payload that a certain fragment arrived. We could also formalize that as metadata. We thought a bit about an isFulfilled field here, which you could alias. And if you see that, then you know a fragment arrived at your component. But actually, it's not so nice because it's a bit hacky. It is more a workaround. So ideally, we want something that aligns with our response shape. And this goes more into a data component. Because when we could alias our spreads here, like our price detail fragment, for instance, we could introduce also a different response shape, where we have now suddenly our fragment as its own shape. So now we are closer to our data component. And that could even be taken further, and we're thinking about something like this, where we actually now are very close to a data component, where a fragment actually can have parameters, arguments that you can pass into, and then you could maybe get two prices in the one component. Now it's usable in a very different way, and because of this new transport shape or response shape, we suddenly could reason about fragments. Meaning, if we optimized the differs and kicked out a lot of the unnecessary or unintended differs, we still could reason about what data arrived. And let's have a look a bit on the transport side. So when we look at the defer transport, we can see the typical GraphQL response here. There's the data shape, where we maybe get the initial data here, maybe users and the me field. And then we get this new pending section, which tells us which data is really deferred. So initially, when we looked at the patches in the beginning of my talk, we thought that we didn't have this pending because we initially didn't need it. But now, when we optimize this thing, we suddenly need to tell the client what we have deferred or what is not being deferred. So in this instance, the server tells us there's coming more data, and this data is in a certain path. And then in consecutive data, we can refer to that and get the incremental patches. So you can see these little nuances that actually introduce difficulties that you often see very late and take long to fix. So introducing these big shifts in GraphQL actually takes a lot of detail work, a lot of implementation that you have to try out. For instance, Hot Chocolate or GraphQL JS implement all these features already today. So you could use them, but you also would have these risks that I showed you, where unintentionally you have these response explosions. So let's shift gears a bit, and there's another cool feature for modern applications, and that is client-controlled nullability. So client-controlled nullability, let me explain it this way. If we look at other modern app characteristics, we can talk also about strong contracts. Like GraphQL is so nice because we have these nice strong contracts, and these enable static typing on our clients. So we call that type emission. Essentially, we generate from our GraphQL types, from our queries, some types for our clients. And it's nice to use that. But the reality is that a lot of fields are nullable. And that is because there is something called non-null propagation. Who here knows what non-null propagation is? Okay, it's one of the basic concepts actually in GraphQL. And, but a lot of users have the same conception. What is non-null propagation? So in GraphQL, let's say price here has an error. So what the GraphQL execution engine will do is set price null. So if all types are nullable, because they are normally nullable, that would mean that the moment this becomes null is that we cannot send a valid response to the user anymore. So what the GraphQL engine does is essentially null the next parent. So we're deleting nodes here. And nodes cannot be null, so we are deleting assets. Assets cannot be null, so the whole result is being deleted, and we just have an error here. And that's why most schema developers actually choose to make these connection nodes, so composite types, nullable. But from a client aspect, this is really rubbish, because now I have to write all these shitty null checks. So what this new feature of client-controlled nullability is about is giving you the power to introduce non-null boundaries, or as I call them, error boundaries. Let me show you. So all this stuff is actually already implemented in Hot Chocolate and many more features. So if you want to try them out, you are welcome to learn some .NET. Give me a second. Let me just get rid of these. And so let's say we have this nice data set here where I fetch all these nice cryptocurrencies. For instance, the Bitcoin, and the Bitcoin has a white paper, and actually there are a lot of them, but only one has a null here, and this can be nullable. So with non-null, with client-controlled nullability, I can now change that. I could say, actually, white paper, my client component doesn't allow null. So I'm saying this is non-nullable. The GraphQL IDE actually cannot do non-nullability, but the server can do it already. So with this exclamation mark, I'm now telling my GraphQL server that I'm not accepting null for this field. And what would happen now is actually that I get an error here, and then everything is nulled out until nodes, because nodes is nullable. But I could also say, okay, this is all nullable, all non-nullable, and then everything would be deleted, and that's actually not what I want, but just to make the point here. So we could now isolate this and actually shape this a bit different and say maybe this guy here, nodes, should be nullable for the elements, but non-nullable for the list. And then we can execute that again. And then we get all the items, but we just null out the item that is not abiding to our non-nullability concerns. So what this feature actually gives us is the ability to set nullability in our client to our expectations, and then let this expectation be fulfilled by the server. That means I have to write fewer null checks in the client, have nicer generated code, and can even do things like that and filter out things that don't fit to my expectation. In this case, the client would just go over, filter all the nulls out, and the rest of the component data is valid. Okay, so there are a couple of other proposals we are working on. And there's, for instance, struct. That's something Benji is very excited about. It's about a new data shape, or new, you could say, improved input types that could also be used as output types. There is like a metadata approach we are working on. Metadata is a better way to introspect, like if you did introspection and wondered that you couldn't introspect actually type system directives, it's a major hurdle for dynamic applications, no-code, low-code solutions. But with metadata, we would enable you to introspect these types over your type system. There's also one-off. One-off is this thing that is around for a long time. It formalizes the tagged union pattern. The tagged union pattern is essentially a structural input union. So we can finally do input polymorphism. And one-off actually is almost finished. We also have that already implemented in our server. But it's still waiting for final approval. There's a new specified by and feature flags. And feature flags is something I'm personally very looking forward to. So you can see there's a lot more coming in GraphQL. So I would say if I look at the feature set that we are working on, GraphQL is taking its biggest steps, evolution steps yet. And there is a lot things you should get excited about. But as with many things, it's not the big splash. If you think about or reflect on GraphQL as it appeared on the scene, it was like Facebook came out and said, okay, this is GraphQL, and it was like amazing. How did they do that? But actually, Facebook worked over 6 years on GraphQL before they open sourced it. And it was actually, if you look at their original REST APIs, incremental steps that they went through to get to GraphQL. So it was not like they came out with GraphQL and said, okay, we found the solution to all your problems. It was more they did these baby steps like we do nowadays. And if you do a lot of these baby steps, you will lead to a fundamental way you improve some technology. So I hope this gave you a bit of insights. I know it was a lot of abstract topics I talked about that we are, it is essentially a bit an insight into the discussions we do at the working group and the topics we are working on. And Defer & Stream is at the moment the main topic we are talking about. We are talking about this every week, once, with a lot of folks from Apollo, from our company. There is from First Dibs, like Rob, he was here at the last meetup, and Benji. So a lot of these folks are putting a lot of energy into this. So, and I think this is if you look from a feature perspective, it's the next subscription feature. And it will put a lot of the guardrails in to, at some point, also go to live queries, which I would also like to see in my lifetime. With that, I'm done. If you have questions, go
Thank
ahead.
you. Great talk. Thanks a lot. It's really nice to see that so much is going on. Like a year ago, I was thinking that nothing is changing in GraphQL actually,
Yeah.
and it's not going to change. But then you have all of these amazing features, so I cannot wait to see that implemented. Like it's really crazy that it's already working somewhere in some servers.
Yeah.
Yeah, crazy. Do we have any questions?
Just for this non-null propagation, it's like in TypeScript when you use explanation mark, it is like a non-null assertion, and also the question mark is non-null. The question mark is also for like being able to go deep. The semantics are different. It's like intentional. Wouldn't be confusing that. You know, in TypeScript, I would say explanation mark to the compiler, trust me, this is not null. But in GraphQL, it would mean if it is null, then throw an error on me. Or
it kind of is an assertion if you think about it. We are asserting it's not null, but when the assertion is false, we are propagating.
Yeah,
and that's why I like more the error boundary explanation. Like you have error boundaries, for instance, in React. It's more like that, where you throw at some point and then you catch it at some other level.
Yeah, but TypeScript doesn't really catch it. It's like a hint to compiler because compiler cannot narrow the type enough. Yeah, I think it's a bit confusing that they're using the same operators that TypeScript is using, a slightly different meaning, but that's fine. And for the stream and defer, when you want to use them, do you also need to use the fragments? The fragments are a way of like labeling the stream or defer?
Yeah, there are so. It depends from where you're coming. Like, I have a strong relay background. That means, so I actually have no clue about relay. But my front-end devs are all Relay developers. That's why they made me think Relay. So that's what I mean with a strong Relay background. So in Relay, we think about componentizing things. So you always think about these fragments. One fragment essentially is a data contract or the input into your component. And that's a way of how Facebook thinks about client development. And suddenly with defer and stream, it's important to know when the data for your component is there so you can render that component. And if we talk about merging fields or even skipping defers that you as a developer, as a client developer defined, we need to figure out on the client side if the data is arrived. Let me give you maybe a simple example here, because like a client component, where we see here asset info, for instance, is a fragment on asset. And here we also have a component on asset. And they could even have the same data. Like when we think about field merging, we say this is actually deferred, but now the GraphQL compiler or the GraphQL execution engine looks at this and says, okay, I don't want to send the same data twice. And actually we know you have the name field already there. So when I send you this payload, because this is not deferred, then you already have name, so I can go and just strike that out.
Yeah, but
It
would
could
it
be the other way
But
around.
if one part is deferred and another is not deferred, wouldn't it be better if defer like degrades to non-defer?
Degrades to non-deferred. How do you mean that?
If it's like one part of the query, like if you are requesting the same thing twice and one part is deferred and another is not deferred,
Yeah.
then they should be non-deferred.
Yes. So that's what's happening here, right? I'm sending you the data now immediately.
Yes.
So what I mean is, so how do you check in the client component that your data is arrived? So if you, for instance, checked, okay, if name is there, then my data must be there because I also asked here for name. Or do you have an equals in all the fields that are in your component? And that's where this fragment indicator or this hack came from, where we could say, okay, maybe we just repeat here the fragment name and then we alias this, and this is our marker to know that this particular data has really arrived. Because when we find this field in one of the payloads, we know that this piece of information is there.
But wouldn't be the has next, there is like this, that there has more data on the response from the server?
Yeah, but it doesn't tell you which component.
Which part
Yeah.
arrived, okay.
That is the thing. You need to figure out which part is there. Another, you have an indicator. That's one thing. So we tried with labels. So this is the iteration that we talked about, I think, in December that I have here. So there we have still the label. That was the first idea to do it. But when we now skip these defers, you don't have the label anymore. So if the server optimizes and kicks this defer out because we detected that you wrote too many defers or it leads to these 3,000 patches that I sent you, then the server just goes, okay, this defer doesn't exist for me because it's actually not a good defer. Then you don't get the label anymore. And then you need an indicator like this, or you introduce something where we essentially marks this with a real component. S is not a good name. So you know, when I actually started as a software engineer, little anecdote here, I was building a component that was called the assembly loader, and I wanted to shorten it, so I called it the S loader, but I didn't reflect what it actually means, and then we shipped it to the customer. And in the documentation it said, okay, use the S loader to... Okay, you learn.
Thank you. Any other questions?
Do I get a second T-shirt or not? Wow. Fine, I will still ask it. Okay, so this is not the first time I see the example. So first of all, I don't know much about stream and defer. I haven't read anything. Sorry. And this is several times I've already seen examples of this, you know, a feature presented in the context of lists. And the motivation is to improve the performance on front end, right? Because you can start rendering something. But as a front-end developer, I think about it, well, okay, so I received some of this data. If I will start updating every single, you know, slot of the product or whatever, the line, I'm gonna create a lot of layout crashing. You know, there's gonna be a lot of updates and my browser will start freezing because I'm doing too much work. So then there's two questions. So I don't know if the user is gonna scroll or is gonna start filtering. So I would expect that I would receive some data that I need, and then I would say if I need other data, like lazy loading. I start scrolling, and then I kind of actually start asking for more data. And the other thing is that possibly another strategy that I might employ is that I would load the images for the above the fold, like 8 items, but I would like to know how many items are there so I can put them in the DOM without the data, like placeholders. So I know in advance it's going to be, you know, 53 items. I would only receive data for the first above default 10 items. So it's all kind of like in CSS structured, and as a user starts scrolling, I can fill in. So I'm just wondering, is that something?
That are very good source, and they're all true. For instance, if we look at this example here, right? As I said, it's not about like endless list here. For instance, we have here the 3 most sought for cryptocurrencies. So when the page is loaded, we get this element here first. But we also deferred other things, like you can see components down here. This component is deferred, and also this component is deferred as one thing. Not the items, but the block. And we use suspense here, so we also use ordered suspense. So meaning because we don't know when the data is arriving, when this data, for instance, the loser's data is arriving before the gainer's data, we actually don't start rendering because we don't want to have these not so nice flipping UI elements. So you have to think about where it makes sense. For instance, this list up here, does it make sense to defer or to stream the items? No, it doesn't, because that is my ticker. So either I get all of the items in my ticker or none. Or maybe it could make sense that you say, I want the initial 5 items, and then it just starts scrolling when new items come in. Could also be. It is very specific to your application where this makes sense. And now I think we decided, okay, we want the ticker completely. Here we need just the first graph. And then also this is as a whole deferred. And also this is as a whole deferred. So we get these blocks as they appear. The coolest thing in the server, we are doing a context branch. So they are now processed in parallel and then really sent down. The same goes really for this kind of data. Look, it doesn't make sense to for instance, defer here the weak data because I never know if my user clicks on them. So we actually load them as it appears. So in this instance, it was in the cache. But if I click here on the months, you can see we are getting it now. So it is really dependent on your application logic. Don't overuse it. Not every list needs to be streamed, or not every block needs to deferred. And it also makes no sense here, for instance, to maybe defer this graph or so, because if I defer the whole graph, the UI doesn't make sense anymore, because just having here the number immediately, does it make sense for my UI? No. And this data below is very quickly there. So this UI, or this screen here, has no defer at all in. So it is, use it in the things where it makes sense. Also, like the example that you said with lists is, for instance, here we use infinite scrolling here, so I can now, it does a scroll call every time the data comes. We are not using streaming here. Makes no sense because I never know if I go down there. But for complex UIs where you have multiple components, maybe the first row of components, you see immediately no defer, but lower level components could be deferred. So there are a lot of use cases for it, but don't overuse it.
Thank you.
Wouldn't be like now React would have soon, maybe not, I don't know how when, but it would have server-side components.
Server-side components? Yeah.
They could probably address some of that as well, where you could make multiple queries and then chunk the HTML back to the browser. And then you could have your main graph executed first and everything would follow through.
Yeah, it depends. It depends all on your use case. So depending if you have a business application, for instance, server-side rendering can be a solution.
Yeah,
but
this is going to compete a bit like...
I don't think it competes, it complements. So we see that in a lot of business applications we do that it actually complements. This application here is written with Next.js, so we're using at some parts server-side rendering and at some parts more direct GraphQL. I think it complements.
More options, basically.
Yeah, it's more like this is your tool set. Use whatever makes sense for your stream. Like a content management system, maybe like a lot of very content-heavy pages where you have blocks and stuff, makes sense to render them with server-side components. But it's complementary.
Okay, thank you.
Thanks a lot. Any other questions? Yeah, we have two, so let's...
Hi, in terms of like a streaming, I see that you might do it somehow manually. For example, if you go to the first page of your application,
yes.
I clearly see something like an islands of this architecture. So maybe it would not be wise to use just one query to fetch all the data. Maybe it would be better to split it to several queries, like the one that will fetch data for the top of your application, then another query for your graph, and then another query for the data that is below. So thanks to that, once any query will be resolved, then you may render the part of your application faster. So how do you think about this approach? Is it better to divide to several queries or do the one only?
So the initial approach for different stream from Facebook, I don't know if anybody remembers, was something they called batch with export. So essentially, it's very similar. You split your queries. But that means you need to maybe aggregate data on the client side. So the very nice example from Facebook was they essentially have a list of news that they fetch, and then they have to collect the IDs from that and then feed it into the comments to fetch the comments for the news. So now you're dealing with these aggregations that we had in the REST side again. And instead of just telling the server, and maybe the server has a much more efficient way to branch off these connections. So while this is a solution that you could use, it might not be the most efficient way. So it's more efficient to write one query, one logical query in your mind, and then let the server sort out how to efficiently get that data. That's the explanation. And the second thing is you have one HTTP post request that you can stream over. So very, very efficient also network-wise.
Okay, thank you.
Thanks for the question, and we had another one here.
Okay, so that wasn't in the presentation, but I'm a little catch on that future flags. Can you like a little more talk about it? Like on what kind of level that future flags will be?
So the idea is, I don't know if it was Yelp or Twitter, but one of these companies, could also be GitHub, had a case where they have like experimental features in the graph. And the problem is once you put something in your graph, you essentially have it there. And the main idea was then to have a feature flag to essentially mark parts of your graph, mark parts of your type system as kind of, we're trying something out. And the idea is that you can then, or the evolving, it's still a very early discussion on that, is maybe that you can opt into versions of your graph. And I don't mean versions in the sense of REST, like I want to opt into these features and suddenly you have the types available to you. Or I opt into multiple of these features, multiple of these feature flags you set on, and then you have available these types. But your standard applications just get your graph as is. So that's essentially the premises of this. And the idea was to more generalize it. The first idea was very simplistic. And now it's worked on to be more generalized so that you have essentially flags where you can mark sections of your graph. But as I said, that these features sometimes start out one way and then change also shape. It's the same thing here. Like for instance, one-off started as a very simplistic thing to codify a behavior that already was there. So tagged union, anybody knows what a tagged union is? Say that? So a tagged union or a structural union is essentially an input type that we use, where each of these fields represents one case, one of our polymorphic cases, one type case. And that's something that, for instance, gRPC uses. And in GraphQL, people try to model that. So we started with one-off, and one-off is almost ready. I need to push Benji to really get the last thing on it. But then the discussion evolved actually in something like struct, like a more powerful way to have input polymorphism. That's why I'm saying like feature flags also is like evolving. So
I get it now. Okay, thank you.
So sorry, maybe this sounds like nitpicking, or but so I really liked your answer actually about the thing, because I received recently a question on GitHub, about using the different stream if we're planning to edit and for the list, and I think what you said is like it not always makes sense to use it. So, but then here's another question: is it maybe could evolve into kind of like a bit of an anti-pattern here, like of people abusing this feature? And one of the things that came to my mind right now is that essentially having this pattern is so convenient, then you stop doing caching, and because you stop doing caching, now seeing all these requests, the compression algorithm is probably not as good, because now instead of having one big compressed chunk that can be reduced in size, I have a lot of small chunks that are not as efficient in compression terms, right? So the amount of kilobytes now is inflating.
Yeah.
And so me as a developer is like, yeah, I would not do caching so that give you the response quicker and more compressed and more efficient. I'll just give you one by one and a bigger payload,
So yeah, so these concerns are good concerns. Actually, we are talking about. That's what I said. When we got into the discussions, or the last things we are working on, the last big issues we are working on, is all about efficiency. Like we want to have this to not deduplicate a lot of data, so that we have essentially the same efficiency as, almost the same efficiency than you have when you would fetch it in one go. And that's why we are talking so much about field merging and also dropping differs in places where they make no sense. And the other thing here is sometimes it's worth sacrificing some bytes for speed. So it's always memory or speed, right? You can have a lot of caching, but then you're using a lot of memory on your client side. But you're sacrificing this memory to gain speed. So sometimes it's worth to sacrifice something. And in this case, I would say, again, every feature can be used as an anti-pattern. So you could say, now I'm actually predicting what the user will click, so I'm always preloading all the stuff that I'm never going to use, and then you're clearly using it the wrong way. But yeah, so use it where it makes sense. And again, we identified a couple of things also in applications that we implemented, so we are using that actually in production. And there is like, for instance, for a Swiss company we are working for, they are using it for where they load the contracts, and there are parts of the data they calculate which are very heavy. But the user will look at them, but not immediately, has not in view immediately. And now it appears on this page as if the data is instantly there, and that's the effect you want to do. But you will still pay the same price as before. Like, you're not making your data come faster, you just have the effect that the user can immediately interact with your application, and that's where this feature fits in. So,
yeah, I want to add to that. I think that's where I started with asking about lists, because I think lists are, you know, maybe not the best use case. And one of the things that we had in mind using Defer was, you know, when you get a basket and, you know, you get the total, the price and of the items, and we have this external webhooks where you're figuring out what the price of shipping is. You know, it's just one of the fields that might take, you know, we give up to 15 seconds for you to figure out what is the price of the shipping, but we want to render the response as quick as possible. So basically, you know, relying on these external APIs, we can, you know, just give you the information that you care about, and the shipping would, you know, arrive later, and that later might be later. But instead of, you know, freezing the whole checkout and like waiting for 15 seconds until, you know, we know what is the price of shipping, we can show you something. And like these use cases are very, very useful, especially in the like event-driven, where you have a lot of third parties that you rely on a lot of answers, you know.
So my feelings, my gut feeling is anyway that Defer is what people will use the most. Stream is, you have to have a real good use case for it. But the thing I think will be actually most used is Defer, because it's also easy. You slap it on anywhere. It doesn't have to be a list. You just mark a section. It doesn't make sense actually to do that here. But you just mark a section and say, this is expensive data. Give it when you're ready. And this is what I predict people will use a lot. And that's also the feedback that Apollo has from their customers. So they started also implementing parts of their solutions with Defer. And this is what people are going to use. Stream, rare use cases. So your feeling about lists is quite spot on.
Thank you.
Thanks. So I think we'll stop here because we are running out of time. I know Michael needs to go back to Warsaw today, but I hope you will stay here for at least an hour or so. So we still have some beers and drinks and stuff. So we can stay here and discuss in the kitchen. So thanks a lot for joining us today, and see you in April for next edition. Thank you.